Hello there, and welcome to another Science Saturday. I'm your host, Noah Mugen. I hope you've had a warm February and a happy Valentine's Day, and we're glad to have you back. Today, we're going to be going over the relationship between surface area and volume, and I'm going to quickly go over the materials that we'll be using in today's experiments. Now, if you don't have all of them, don't worry, it's easy to follow along. Today, we'll be using butter, food coloring, scissors, water, and any sort of sponge or like magic eraser that you're able to cut up. Now, aside from Groundhog's Day and last year's Snowvid, one of the biggest events in February is, of course, Valentine's Day. It's a great chance to show your loved ones and friends how much you care about them, and honestly, the chocolate alone makes it pretty great. Which is very convenient that it is in February and not something like August, because if I tried to take like a baggie of Hershey Kisses out in the middle of the Texas summer heat, well, I'd probably end up with a puddle of brown melted chocolate in like half an hour. But that does bring up something interesting. Different materials will melt at different speeds, even if they're made of the same stuff, as long as they're in different shapes. I could get a chocolate bar, and if I break it up into all these little pieces, it will actually melt faster than if it was just one whole piece. How does that work? Well, that's what we're going to be covering today. Now, first off, let me just show you this in action. I'm going to be using butter for this experiment instead of chocolate because I'm not going to waste an entire chocolate bar in a Science Saturday video. Like y'all, but not that much. So for this experiment, you're going to get some butter, a cutting board or a plate, and a knife. Take the butter out of its packaging and just cut it into two halves and place them on the opposite corners. One you're going to leave in a block like this, but the other you're going to cut into a bunch of little pieces. Kind of dice it up. Now once you've got your butter all cut up, let's put it in a pan. On one side you have the block. On the other side you have the other block that you've now cut up into all these little pieces. The same amount of butter is on each side of the pan. When we heat this up, let's see which side melts first. And would you look at that? The butter that was all cut up melted much faster than butter that was just in a block, even though it was the same amount of butter. We're going to get into why once I turn all this off and try and keep myself from being burned by the boiling butter. How exactly that happened has to do with the relationship between surface area and volume. Surface area is basically how much room there is on the outside of an object. You can visualize it by saying, well, if this object was a present and I had to wrap it with wrapping paper, how much wrapping paper would I need to completely cover it? That's the surface area. You can find the surface area of a square by multiplying its length by its width. For this square, which is one side of a Rubik's Cube, each side is 3 blocks long. So you have 3 width and 3 length. If you multiply them, 3 times 3 is 9. So one side of this Rubik's Cube has a surface area of 9 blocks. You can also just see this by counting the blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if you wanted to find the total surface area of the entire cube, which is all of its sides, you can just add up the surface area of all of its sides. A cube has 6 sides, so then it's just 9 times 6, or 9 plus 9 plus 9 plus 9 plus 9 plus 9, which equals 54. Overall, this cube has a total surface area of 54 blocks. Now you could actually go around and count every single block on this cube, and you get 54. I'm just not going to. But hey, if you have a Rubik's Cube at home, feel free to test my theory. Volume, on the other hand, is how much space an object takes up. If this were a present, for example, you could say, well, how much room would I need in a box to put this present inside? Unlike surface area, which you can find for a two-dimensional object, meaning that only has length and width, to find volume, you need a three-dimensional object. So it needs to have length, width, and height. It's something that you can pick up in the real world. To find the volume for a cube, which is a shape with squares on every side, you need to multiply its length by its width by its height. So for this Rubik's Cube, since each side is 3 blocks long, we can find its volume by multiplying its length, which is 3, times its width, which is 3, which equals 9. And then that 9 multiplied by the 3 of its height equals 27. In other words, this cube has a total volume of 27 blocks. Something interesting happens as I change the measurements, however. If I were to make each side of this cube longer, the volume would actually grow faster than the surface area would. For example, if we have a cube, this cube, with 3 blocks on each side, it has a total surface area of 54 blocks and a total volume of 27 blocks. However, if I made it so that each side of this Rubik's Cube was 10 blocks long, it would have a total surface area of 600 blocks, but its total volume would be 1,000 blocks cubed. Its volume would then be larger than the surface area, even though when it's like this, its volume is smaller than the surface area, and I increased the lengths for each side equally. This is because the side measurements only come in twice for the surface area and length and width, but they come in 3 times for length, width, and height. So if I increase every side, the length of every side of a cube, I'll be increasing the surface area in 2 different ways. I'll be increasing the volume in 3 different ways. In this way, making each side of this cube 1 block longer, for example, would have a larger effect on volume than it does on surface area, because I'd be increasing each of these by a factor. And since volume increases in more ways than surface area, the length of the sides has a larger effect on volume. It works in reverse too. If I were to decrease the length of each side of this cube, then the volume would be much, much smaller than the surface area, because, as I said, every side length has a greater effect on volume than surface area because they come into play more times. Now this has been a whole lot of math, and I'm sorry, but why does it matter? Well, it goes back to the butter from earlier. When I cut the butter up into the 2 separate pieces, the 2 groups had the same amount of volume, because if I had gotten all the little pieces and put them back together, they would have taken up the same amount of space that the block of butter did. However, when I cut up the block into a bunch of little pieces, I decreased the side of each of the pieces, the side length. And since side length has a greater effect on volume than surface area, their volume decreased much more for each little piece than the surface area did. Therefore, in total, while their volume stayed the same, the surface area got a lot bigger. Now, this may be hard to visualize, so just look at this. When I have this block, I'm going to cut off a little piece of it. Now, there's still the same amount of volume because I can put it back together and it'll be like nothing happened. However, when I take this off, now this side and this side are now both part of the surface when they weren't before. So I've just made new surfaces to increase the total surface area. This is important because things like heat or water can only enter an object through its surface. So if an object has a larger surface area, then it can take in more of that heat or other materials. On the stovetop, for example, the butter that was all cut up had a larger surface area, and so heat from the stove was able to enter it from more directions. Thus, it was able to heat up faster than the butter that was just stuck in a block, which only had a much smaller amount of surface area, and so the heat could enter it from many fewer areas. You can actually show this another way with scissors, a white sponge, food coloring, and some water. Cut up the white sponge into blocks of 3 different sizes. Now, mix the food coloring into the water. You don't need a ton, just a few drops. And I forgot to get it. but I can just use this, stir the food coloring with the water to make the water kind of a nice, bright, whatever color you're using. This is an extra piece of the sponge, that's why I'm using this to stir. Alright. Now, we're going to dunk each of these pieces of sponge into the water. Don't do it for long, just kind of like dunk in and out. Okay, first off, this one. And we're done. This one. And we're done. This one. And we're done. You can already see that because this block was larger overall, so it had a larger surface area, the food coloring wasn't able to reach the center. Now, let's cut them all open to see what it looks like on the inside. Here, take this one. This make me hungry for watermelon. Now, as you can see, the smaller block was able to have pretty much all of it soaked in the food coloring. This block had less, but it still was pretty full with the food coloring. And with the largest block, all the food coloring wasn't even able to get to the inside. This part is still white. Because this block was smaller, and so its surface area was much larger than its volume was in comparison, look at this one, the water was able to enter it from much quicker. If we had had two blocks of this same size, they would have filled up this same speed because their surface area will be much larger than this block's total surface area was. So if I had got this block and dunked it in there, and I'd got a block of the same size but cut it up into a bunch of little pieces and dunked it in there, all of those little pieces would have been completely soaked because their surface area allowed the water to come in from many more sides than from this block, whose much smaller surface area compared to its volume meant that it couldn't reach the inside. This is why our bodies are made of so many tiny little cells. Because they're all divided and the whole mass of our body is cut up basically into all these little cells that then join together, they have a much, much higher total surface area, which means that stuff like water and materials and nutrients can pass through our body much quicker. And if a little cell needs to escape or go somewhere, then its volume, because its sides basically are much, much smaller in measurement than our total body, its volume is extremely small, especially when compared to its surface area. That way, it can transport materials much, much more efficiently. And that's why chocolate can melt at different speeds. If you break it up, then you increase the total surface area, and so heat can enter it much quicker. Well, I had fun learning about heat and how, surface area and volume can interact to affect melting speeds, and I hope you did too. Stay safe, have fun, and a nice spring break, and I'll see you next month. Bye-bye.